Good morning. Good morning. It is exciting. It is a beautiful day. Today is Thursday. Today is Thursday, and we are so excited about being here. Being here. It's Thursday. It's another beautiful day, and we need to go ahead and get started. So, you know how we begin? We begin with our pledge. I am smart. I am gifted. I am a learner. I am a scholar. I am preparing now for my future. I am the main ingredient in my success. Every lesson won't be easy. Every concept won't be learned the first time. I may get frustrated, but I won't give up and I won't quit. I will try. I will strive. I will thrive. I will achieve. I will succeed. For I am an example of excellence. Clap one time. All right. So we're going to begin by just reviewing. I know I've given you a couple days to do this, and by now you should have gotten it done. So the three read protocol is nothing new, but we want to make sure that you've mastered it as we move forward. So the statement says the Parent Teacher Association at your school donates school supplies to help students' creativity and student success in the classroom. Your teacher would like you to create kits that include one package of colored pencils, one glue stick, and one ruler. When you receive the supplies, you notice that the colored pencils are packaged in groups of 12 to a box, and the rulers are packaged in 30 to a box, and glue sticks are packaged 4 to a box. Now, the color pencils are 12 in a pack, 12 boxes of color pencils per case. All right. So first read, you tell what the situation's about. So what's the situation about? You could say something like PTA is putting together school supplies, and your teachers want you to build some kits. All right. What are the quantities? Well, you have in your kit, you're going to include one box of color pencils, one glue stick, one ruler. Color pencils come 12 boxes per case. The glue sticks come 4 per box. The rulers come 30 per box. Those are your quantities. So what are the situations? I mean, what are the possible questions? Possible questions could be what? First possible question could be, how many are you preparing for? Is there a set number that you're supposed to prepare for? How many students are in the school? Those are questions. If not, how many, since there are only 4 glue sticks in a box, then how many glue sticks will you need to make sure that every glue stick goes with a pack of pencils? How many extra boxes will you need? Those are the questions that you're going to be thinking about, some of your possible questions. Now, the second part was to solve it. So the first part was to read it, but the second part is to solve it. To solve it. So the question first asked, question number 1 is, what is the smallest number of each supply you will need in order to make the kits and not have any supplies left over? Okay, so that means we need to come up with the same amount of each number, the least common multiple. We talked about that yesterday or on Tuesday. So the least common multiple between 4, 12, and 30 is what? Is it 30? No, because 4 cannot be divided evenly into 30. Is it 12? 4 can be divided evenly into 12, but not 30. So is it 40? Can't be 40 because 30 cannot divide evenly into 40, and neither can 12. What do you think? 60. 60. 60 would give you 60 rulers. All right, so 60 will be the smallest number of each supply. So you need 60 rulers, 60 packs of pencils, 60 glue sticks. And that would be the smallest number of each supply you will need in order to make the kits. All right, so how many, number 2, how many packaged rulers, colored pencils, and glue sticks will you need to order to make the kits? So you know you're gonna make 60 kits. So how many boxes of colored pencils do you need? Well, what do we know about the colored pencils? How many are in a box? There are currently 12 in a box. So how many boxes will we need to equal 60? We would have to divide 60 by 12, which will give us what? Good, 5. So you're going to need 5 boxes of colored pencils. What about glue? So there are 4 glue sticks in a box. In order to get 60, we're going to need to divide 60 divided by 4. That's 15. So we're going to need 15 boxes of glue sticks. What about rulers? How many rulers did we say are in a box? 30. How many 30s are in the number 60? 2. Great job. So we're going to need 5 boxes of colored pencils, 15 boxes of glue sticks, and 2 boxes of rulers to ensure that all 60 of the packages or all 60 of the kits are complete. Now, the second part is to explain. So each of these answers should not just have numbers, but they should also have an explanation. Use your words. We want to be able to hear your thoughts. So Tuesday, you were able to begin looking at reviewing the 8 math practices. And if you remember, there are 8 math practices, and you were able to review them through your exercises on Tuesday that are due tonight by 11:59. So I wanted to continue with that thought of math practices today and just do a little bit of review. This is the first week, so it's time for us to kind of review what we've learned. You're in 6th grade now, so we're reviewing what you learned over the course of the 5 prior years, sometimes 6 prior years, if you were in kindergarten, or 7 if you began in pre-K, that you've been learning in formal instruction. So when we talk about reasoning mathematically, what we're thinking about is reading, which is what we did the first part of the 3-read protocol, where we make sense of the task by reading and making sure we understand the task. Then possibly we begin doing the second phase, which is writing. That's thinking and reflecting. So we begin to write about it, to write out our questions, to write out our thinking, to write out our answers. The third way is through discourse. What's discourse? That's conversation. So speaking and listening. Now, look at this, speaking and listening. These are things like turn and talks, right? This is the opportunity for you to say what you're thinking, but also to listen to the thinking of other students. And this is understanding and using the language of math. You must be able to use the language of math. And then the last part of reasoning mathematically is modeling, real world problem solving. So that's representing scenarios with mathematics. That's solving it. That's giving examples of it. That's putting your mathematical knowledge into real world practice. And that's what we're going to be doing a lot this year: reading, writing, discoursing, and modeling. So when we talk about the moves of student discourse, it's working with ideas, student discourse moves. So the first thing is to tell or explain the idea. So that's when the teacher calls on you and says, please tell or explain your idea. And this is how you begin. You say, you will begin with things like, I think, I know it will work because the best strategy would be. Now, the second move of discourse is to clarify. So that's clarifying someone's idea. So when you're trying to get clarity, you would say something like, say again, please. Or what did you mean when you said, or are you saying that? Or if I hear you correctly, this is what you're saying. And it's the idea of seeking clarity to an idea, concept, or statement that possibly could be unclear. The third move is to restate or summarize. So when you restate or summarize an idea, you would say something like, he said, Peyton said, Kira said, Christian said, or in other words, so and so and so, or the suggestion was made. So you're paraphrasing, you're restating, or you're summarizing a previously stated idea. Now, there's also the move of comparison. So when you compare ideas, you would say the same, or ours is better because, or the new strategy is more efficient because. Now, comparison works both ways, because sometimes what you offer is better. Sometimes you realize through listening and observing other person's suggestion that their idea may be better. Or you may find, thirdly, that you both have equally efficient and effective strategies at solving or reasoning in a problem. That's where that first response, the same, comes from. A fifth discourse move is the idea of support. So when you support an idea, you say things like, good idea because, or remember, it said in our notes that, or the advantage of that method is, that's providing support. A sixth move is to build on. When you build on an idea, you say something like, let's try that, or we should change our model to show that, or that idea would help us figure out why. The idea is you take what someone said, like, I agree with Famal, but I want to add, or I believe that Malachi is right, but I also would like to add that. So we're taking the initial idea and we're either adding to it or we're putting it in place to test it. And the final move of discourse is to question or challenge an idea. And what you would say is something like, why? Or, but that doesn't explain what we saw when. Or, is there a more efficient way to? It provides question and challenge, remember, of the idea, but not the person. So again, part of the key to discourse is that we're challenging, supporting, clarifying, explaining, comparing, supporting, building on, or summarizing ideas. This is not personal. This is academic mathematic discourse where we're able to engage ideas without getting in our feelings, without feeling some kind of way, without becoming hurt, but able to challenge ideas because the ultimate goal is to become smarter, to solve problems more effectively and more efficiently, and to become better. That's the key. We're just trying to be better. And we become better by working with each other so that everyone becomes better, not just one isolated person. All right, any questions about this before we move on? All right. Now, this class is going to use conversation. We're going to have table talks, and we're going to have turn and talks, and we're going to be able to communicate in breakout rooms throughout the course of the class. And so what we need to prepare for is how to have conversations successfully, how to have successful conversations. So these are the norms for accountable talk in the classroom. These are the norms. Norms are our standards. Norms are our accepted procedures. So the first norm is to listen attentively to one another without interruptions so you can paraphrase and build on each other's ideas. Here's the thing. If you don't listen appropriately, if you don't give the opportunity for the person to have uninterrupted statements, then you could potentially miss their concept, miss their idea, and miss the opportunity to fully understand what they state. So you could end up incorrectly paraphrasing or unsuccessfully building on the other person's ideas. Here's the second norm. Respect the right of each learner to speak, take risks, and share claims that are supported by evidence. You should be able to give the person the space without laughing, judging, interrupting, or critiquing until they have taken the full time they need to make their statement, share their claim, and support it by evidence. Don't cut them off. Give them a chance to speak. Don't disqualify their statement. Don't discount their chance, because that could possibly lead to them not taking the risk the next time to answer the question. Here's number 3. When you make a claim, support it with evidence that is specific and accessible to the group. Making a compelling argument requires linking together claims and evidence, facts, in a logical, coherent and rigorous manner. In other words, you're not just saying what you think, you're giving evidence to support with facts. Number 4, examine evidence critically. The facts of an argument must be credible, relevant, and qualified. Challenge the soundness of each other's evidence and quality of reasoning. So, as you're examining and critically thinking about what has been said and suggested, it's very important that you're able to make sure that the facts are credible, relevant, and qualified, and you challenge the soundness of the evidence. You don't challenge the person, you challenge the claim. That's the last point. Look at number 5. Disagree respectfully. Challenging a claim, not a person. You should never say, "Oh, that's stupid," or "you're dumb." You know, that's not appropriate accountable talk in the classroom. You must say, "I respectfully decline," or "I respectfully disagree." So I respectfully disagree with your thinking or your statement about your thinking. You know, I do not agree. I appreciate your input, but I don't agree with the information you input. You inputted. But think about that. I don't agree with the information you offered because it was not right. The information was not right. Not that you weren't right. You gave a great attempt, but the information you gave was erroneous, was filled with error. All right? So we must be respectful in our conversation. And that respect trickles into every class, not just into math. You should be respectful in reading language arts or English language arts. Should be respectful in science and social studies. You should even be respectful in physical education, in media, in music, in every class, in guidance. You should be respectful, because the reality is it takes a big leap of faith and confidence to give an answer, to speak out, and it could be damaging if you don't give the person to give their answer without making a face or without thinking or critiquing them in such a way that leads them to not want to answer the question the next time. All right? Any questions? Y'all are really doing well. All right, reasoning mathematically with data visuals. So you're going to see graphs, you're going to see charts, and mathematical literate students are able to analyze, reason, and communicate ideas effectively. This is reasoning mathematically, goal 2. As they pose, formulate, solve, and interpret mathematical problems in a variety of situations in and outside of the classroom. So you're going to be able, your standards will require you to reason abstractly and quantitatively. That's your second standard, math practice. Construct viable arguments and critiquing the reasoning of others. That's math practice number 3. Model with mathematics. That's math practice number 4. Attend to precision. That's number 6. And look for and make use of structure. That's number 7. So the steps to follow in reading data visuals is to identify the type of data visual. What is it? Determine the topic. Examine the given information from the data visual, including the introductory text. Oftentimes, if we would just read the instructions, the informational paragraph that goes along with the visual, we would find out so much information. Develop predictions, deductions, that's number 4, inferences and conclusions about the data visual, and then analyze the questions and determine the information needed from the data visual. Any questions? In fact, one of your assignments for the day is going to require you looking at a data visual, looking at the number of hours worked versus the amount of money made. All right, so, and this is the last chart before we get into our assignments for the day, and that is, what are our approaches to problem solving? So what are some strategies? You're 6th graders. So we're trying to develop critical thinkers and reflective practitioners, those that can see a problem and not get frustrated, not run for help, but take the steps necessary to think their way out of the problem. So here are some strategies. First thing, draw a diagram. Draw a picture, draw a diagram. Try to solve what you're thinking. The next thing, look for a pattern. What are some patterns? The next strategy is to work backwards. Work backwards. Solve it, then work back, especially in the explaining problem. You're thinking about explaining your thoughts, work backwards. How did you get to the solution? Use logical reasoning. Solve a simpler problem. So if you're going to have a problem today about the area, and they're going to give you one side of a rectangle. So if you know that area is length times width, and you're trying to figure out how to figure out the missing side. And so they give you that the area is 3,000 square miles. And they tell you that one side is 480. And you're trying to figure it out. Well, you may start off with something simpler, like the area is 63 square inches. And they told me that one side is 7. So how do I figure out the other side? I divide. Oh, so if I divide for this problem, then I'll divide for the bigger problem. Oh, okay. Make a table is the next way. Guess and check. Sometimes you have to make a reasonable guess and check your answers to see how close you are to the correct answer. Make an organized list. All of these are problem-solving strategies that you're going to use this year to solve some of these amazing problems we have. Okay, so listen, I've overwhelmed you today with some reminders and refreshers about reasoning mathematically, about approaches to problem solving, about effective ways to communicate and to argue and to address and to have accountable talks in the classroom. So as we wind down, we have 3 assignments. One assignment is a critical thinking assignment, and the next is a pre-assessment, I guess. I would call it an accountability check, just to see how a readiness assessment, that's probably a better way to say it. It's an assessment that's going to allow you to see where you are so far coming into the 6th grade. So here's the first one. This assignment, and it will be in your Google Classroom under your assignments along with this video. It's dealing with rational numbers, reasoning mathematically, equivalent expressions. So we're going to talk about these, but the first thing I want you to do is I want you to work on these yourself. So I want you to choose 3 of them and figure out if this equivalent expression is true or false. So that means, does the left side of the expression equal the right side of the expression? If it's true, they equal. If it's false, they are not equal. And either way, I want you to explain your thinking. But I only want you to do it for 3 of them. So you could choose to do the even numbers, you could choose to do the odd numbers, and then add an additional one. There's question number 4, ask you to look at questions number 2 and 3, the left side, and see what is the use of the number 6. And then question number 5, question number 5 asks you how is 6 related to 42 and 12? That's the first assignment. Here's your second assignment. So it's 10 questions, but you're not going to have to do all 10. It is a readiness assessment. And so I want you to choose 5 of these questions and answer them. So you have one about area. You have one about Jerry having a 3rd quart of ice cream and wanting to share it with his friend. You have several about number lines. You have some where you are charting coordinates on a graph or on a map. You're doing some division. So out of these 10 questions, I want you to choose 5 of them and solve them. You can either do all even, all odd, or a combination of the 2, but select 5 of the problems and solve them. All right. So again, listen, this will be due on Tuesday. Monday is Labor Day. This will be due on Tuesday. So excited about all that we have been doing. Keep it up. Keep it up. Keep it up. All right. Any questions? Ms. Johnson will be able to answer any questions you have. You have an amazing day.